So I'm Ed Hicks. I'm here at Oshkosh with Rian Johnson, who's the president of Vans Aircraft, and it's obviously they've just unveiled the RV-15, and it's here with us. Rian, thanks for joining us.
I'd like to be here with you guys. It goes back many years.
Yeah, I'm probably
many years.
20 plus now.
Great magazine, yes.
Yeah. So Rian, where did it all start with the 15, and how long ago was this just an idea?
Maybe as far back as 2000, 2002. I don't know how far you'd have to go back. I mean, Van and I have always been talking about this back and forth from a design sense and gathering ideas. It hasn't been a short-term design process. And the first step was just building an engineering crew that had the capacity to design and build this airplane.
Yeah.
So we've been missing that over the last few years. The expansion of the business has taken so much extra engineering capacity. So I built a great crew over the last few years, and we've finally had an opportunity to design the airplane we've been thinking about for some time. So I would say over the last 10 years especially, the design has slowly come together. Right now, we've seen a hole in the market, and there's a lot of airplanes that start out as powered by smaller, less horsepower engines.
Yep.
And they've tried to expand those airplanes, put larger power plants on them, but it's just, the airframe is still the airframe.
Yeah.
And you can only do so much with that airframe. There's only so much baggage capacity. So we wanted to go out and have a real STOL airplane, but not too far off the STOL end of the spectrum either. So we're not out there to win the Valdez STOL competition, right?
Yep.
But total performance is that happy medium where we hit a lot of base hits and we get the home run in the end.
Yeah. So you've aimed to make this, it's not about big tires and...
Doesn't have to be.
No.
Because of these landing gear right here.
That's it, yeah. Well, that's probably a
Right.
good pointer. What are the key things that are really unique to this aeroplane?
Sure. The one thing that we had to have in this market, and I learned to fly in a J3,
Yep.
which has the standard controls. It's from an era in which you have fabric, you can't hold that airfoil shape, and you have cables, and cables stretch, right? So you would get displaced in the airplane, put the control over, and wait for a response. We wanted that RV handling in this segment of the market. The thing about RV handling is, when you fly an RV, you fly in this spectrum of the control movement. But when you need it, and it is a safety item, you can expand out to here. So I wanted effective ailerons, but I wanted ailerons that were an extension of your thought process, just like the other RVs. In this airplane, we've achieved that. So these ailerons, we've expanded the flap. These are the largest chord ailerons that we've ever designed at Vans. They're 34% instead of the old 25% in the other airplanes or less. And we've still managed to have that crisp feel and eliminate adverse yaw.
Okay. And just touching on the flaps, obviously big Fowler flaps, aren't they?
Yes.
We've seen the tracks. And so tell us a little about those, and obviously you've brought a stabilator along to the aeroplane as well, haven't you?
Sure. When I laid out the airplane, initially I compared 60 different airplanes in grand detail. So I made ratios of everything and compared them to my calculations. And so now you start laying out an airplane, and there's some airplanes that I appreciated. And that was a small grouping that we really drilled down into. One of those is the Helio Courier. So you'll see some of the Helio Courier in the ailerons and in the stabilator. Now when we look at a stabilator, I'm hangared with another STOL aircraft.
Yeah.
And I watched them fly. Obviously we've done a lot of study. And when we think of a stabilator, those airplanes, they get right near landing. You're coming in on that sandbar, and at that point, you run out of elevator authority. And so you're pulling back on the stick, and there's nothing left. So you end up gunning the engine to get that air to come over top of that control surface.
Yep.
We knew from our experience with the RV-12 that had a lot of authority. And so we could get more authority out of a smaller control surface, lighter weight. We wouldn't have to put it as far back. and still have the controllability even at slow speeds. The slow speed handling is key here.
Okay.
So that's the stabilator. Moving on to the flaps. We do have large flaps. They're an experiment. It happened that Van and I were in Salt Lake City at a gliding competition, and there was a bird dog pulling the gliders up into the air.
Yep.
And it had large flaps, and we could tell that you drop those flaps down and you're starting to fly on drag.
Yeah.
So it's different than just flying on a lift coefficient. So you're flying against that drag, and in a way it gives, if you get used to it, some stability to the airplane, and you can actually have low speed control in that format.
Yeah.
We might have too much flap. I don't know. If we do, we can take it out. We can take it out and travel or span. But right now, we wanted to try some extremes. So for this airplane, you'll see that it's possibly a little bit too short.
Okay.
I can always lengthen it back out. I fully intend to do so if I need to.
Yeah.
But there's nothing like trying the stabilator as close to a large flap as possible, right? If I know that works, it will definitely work here.
Yeah.
And the same with the flaps. Let's try the large flaps. If we have to adjust backwards, we've at least gone out and tried, the aggressive maneuver, so to speak,
Yeah.
and learned what we could.
Yeah. And it's a totally unique airfoil to the aeroplane, isn't it?
Yes, it is.
Not used on any other RV.
Correct. So one thing that we have in this airplane is a much larger span than the other RVs. This is a 34-foot span as designed, and it came out with the Horner wingtips at right around 35. I will bring the span into at least 34 because it gives margin to a standard hangar.
Yeah.
But when we look at that span, if you stall an airfoil that has a sharp drop-off on the lift alpha curve, you can get effects where the airplane will really drop off. And if you're stalled right above on approach in a stall configuration where you're trying to make a spot landing, I don't want something that's going to be aggressively dropping off.
Yeah.
So I wanted the high lift coefficient of the 23,000 series, but I also wanted more docile stall characteristics. And so in this airplane, we've combined multiple airfoils together is where we started, but then we tweaked it further through computer-aided design. We used Steve Smith, who helped us design the airfoil on the RV-10.
Yep.
And he was happy to join this project and figure out what it was early on.
Yeah.
And so Steve was a great help, and this is a unique airfoil to Van's aircraft.
Yes, yeah. And undercarriage-wise, obviously you've designed a completely unique gear for it, haven't you? And that's the same on the back end as well with the tail wheel.
Right. Maybe let's start with the airfoil there again.
Oh.
On that. So what drove the landing gear request, and that was to put the gear suspension system inside the fuselage. I knew I wanted to reduce the drag there.
Okay. Yeah.
But let's look at the airfoil again. The same thing applies. A lot of STOL airplanes use airfoils with a lot of camber. That does two things. One, you have to carry the flap around with you all the time. You can never get rid of it. So in high-speed cruise, you still have the flap slowing you down.
Okay.
The other thing it does is it has a high pitching moment. So one benefit of this airfoil is it has a fairly low pitching moment. The 23,000 series airfoil is a factor of 10 less than the old airfoils that were used on a lot of airplanes through the 60s and 70s. So that means less tail required to balance that wing.
Yep.
So that's extra speed is why we did that.
Yeah.
So there was an intention, we wanted this airplane to still have a good cruise speed.
Yep.
So coming to the gear, on the main gear on this airplane, we have packaged between a flat floor, from the front of the compartment to the back of the baggage compartment. It's completely flat.
Okay.
And in the front, we have about 5 inches of depth. And inside that, we've packaged 2 gas struts on either side with 5 inches of stroke.
Okay.
So when we think about that outside the airplane, we no longer need 31-inch tires if you have 5 inches of stroke.
Yep.
And you're not paying the weight penalty for those to be on the wheel vertically or to be crossing over the airplane in a bungee setup.
Yep.
Very reliable. It's also tunable. So on those gas struts, they're nitrogen filled, but you could also, if you were in the bush, just get out your hand air pump. We have an air pump along with us, a hand air pump, and you can tweak it. You want it stiffer or softer.
Okay.
And you combine General 26 wheels
Yep.
which will get you over the topography,
Yep.
and then you'll have the suspension.
As well.
The other thing we've done on this airplane is designed a unique tail wheel, and I must say that we patented both of these configurations. So both the main landing gear, but the tail wheel is relative to a race car suspension system. It's the only tail wheel that has constant caster angle through its whole throw. So most tail wheels, as they drop down, they'll start to shimmy.
Okay.
But if you keep the caster angles the same and it's set up appropriately, you eliminate that shimmy. We also have a gas strut on the tail wheel itself.
Okay.
Now we'll have better fairings around that, obviously, but right now that will take, the whole airplane can just come down and you can plant that airplane and stay planted. Okay. And it'll be much more forgiving airplane.
Okay. And inside the cabin, so obviously we see that it's it's 2 seats, but it could be bigger than that, maybe?
Could be. It's a favorite question. Yeah, more than 2 seats is possible. You'll see tomorrow in the presentation, we made the wood mock-up. We had 2 little girls back there, some of the kids and the engineers, and they fully intend to build it that way.
Okay.
If you were going to build it for a normal size adult to sit back there, you're going to lose baggage first.
Yeah.
But also you'd have to do something like the RV-10 and put the cushion right on the floor.
Yeah.
Because headroom is limited in this fuselage where it's coming down.
Tapering, yeah.
So yes, you can have 2+2. Now let's talk about the tri-gear version of this airplane. So we're fully anticipating the expansion of Mosaic. It's already happened in Brazil, but hopefully it happens worldwide, right? Where you can build LSAs that are much larger than before.
Okay.
When that comes along, I fully anticipated during the design of this for it to be a tri-gear trainer.
Oh, okay.
So a larger training aircraft.
Yeah.
And one thing that's popular with the flight schools is a third person, an observer seat.
Yeah.
And we fully intend on supplying that to the training market.
Okay. Yeah. And baggage-wise, obviously, big flat floor, lots of space. The doors are, I think lots of people have been surprised at how big the doors are. And I think you can, you've mentioned to me that you can put a full-size bike in through the doors quite easily.
The real impetus for the doors being large was not the baggage, that was a side benefit, second. The real impetus was I had got in and out of many airplanes. Van and I would go around to Oshkosh, and of course Van is getting a little bit older. He's very nimble, but still you watch him get in and out, and there's people that, they just have a problem getting around a control stick, especially in a high-wing airplane. So I wanted to be able to slide the seat all the way back to the B-pillar, and then the control stick is in a D shape. So you push the control stick all the way forward, and you can easily swing your legs in. So this corner of the fuselage right here is designed around your toe to swing in, and then behind that D shape in the stick. Now, the seat here was purloined off of a Cessna, I will admit. We needed a seat quick, right? We went to the wrecking yard, we grabbed seats, and we came home. But in the future, that seat will have a slot in it. So you can slide the seat up around the control stick. You'll have a control lock built in for weather, but also, you can also easily then, without taking the seat out, slip a full-size mountain bike, and we'll show a video of this tomorrow. Tomorrow we'll put the mountain bike in here, but you can slip a full-size mountain bike in the airplane. Now this baggage bulkhead doesn't have it, but in the production baggage bulkheads, we'll have a slot for that back tire. It'll sit right in there, it'll keep it upright. We're talking full-size mountain bikes, not small ones. So this comes from the fact that you may or may not have a bike where you're going, but it's nice to have it with you. So it's about the volume. And that's what really expanded this fuselage, was the volume to carry real gear that you would want to use to a destination without paying the weight penalty for everybody of putting it in a pod, and maybe it won't fit in the pod. Right? So there we go, and that's the getting baggage in and out. We also have a baggage door. We just want to get in the air and test the aerodynamics in this airplane. But there will be a baggage door in this airplane. Last year at Oshkosh, I was designing the baggage door. I took Rob Heap, our director of engineering, around. He's 6'4" and has shoulders this wide. And I said, try out the baggage door. So we designed a baggage door for his shoulders, or a Coleman cooler, to be able to go in and out. And it's at the back, so obviously you want a baggage door to catch what rolled backwards when you have it on the large tires. Pull it out.
And power plant wise, what are you looking at using?
two different power plants, designed the airplane around the 390 really.
Yep.
And there's something about power plants. When you offer a range, it seems these days that people just go to the upper option, right?
Yeah.
But still, I like a lightweight airplane. So I wanted to allow the lightweight 180 horsepower option.
Okay.
There's a lot of lightweight 100, and that will move this engine further forward in that configuration.
Yeah.
It won't move it forward enough to allow the same amount of baggage as a 390.
Yeah.
But that's convenient because more power, more baggage, safety is retained, right?
Yes. Yeah.
So you'll have the 180 horse, and then you'll be able to use the 390. Recently, a couple years ago, we developed the EXP 119 project.
Yep.
That was really for this airplane.
Huh. Wow. Okay.
So it had the side benefit of making the 14 go as fast as 180 knots plus, but it was really for this airplane. We took the 14 engine package and put it on this airplane because we didn't want to test fly on an engine that didn't have any hours on it.
No.
So literally this is the engine package off the 14, picked up lock, stock and barrel, and put onto this airplane.
And the EXP is around about 215 horsepower?
At least, if not more. We think we get a little bit more from it. We use the cold induction. We've somewhat tuned the exhaust. You can never tune the exhaust on this short of pipes. And we also have that cold, besides the cold induction, the larger throttle body.
Yeah, okay. And just, I know it's something I've spoken to you about personally, but I know you put a big fin on this because I know you want to build a bush plane that goes on floats, don't you?
We do.
Yeah.
I don't want to, why a big fin and why the shape of the fin? Two different questions. The design of the vertical stab and the rudder is more about the size of the punch press we have.
Yeah.
We had to order a new punch press from Germany to make this airplane.
Right.
And it is 20% longer and 20% wider. But if you think of taking a rudder skin and flattening it out,
it's big.
that's how much the rudder can be, the chord of the rudder.
Yeah.
So this is probably taller than it needs to be. I can tell by the control handling of the airplane that I will need to reduce it vertically slightly.
Yeah.
And I'll play with the counterbalance area, etc.
Okay.
But it was, again, when I laid out the math of the airplane, that's what I thought it would need. When it comes to a float plane, where I'd like to go there, now that we have the larger punch press, is a larger rudder for those folks.
Yeah.
Right? And then everybody else gets to use the shorter chord rudder.
Yeah. And just listening to you talk to people earlier, I'll just run through some numbers that I thought I heard. 900-pound useful load, possibly?
Yes.
Maybe around about 140 knots. Who knows?
Yes, so the cruise without the big tires we know by coming to Oshkosh, it will be able to meet 140 plus in the cruise configuration.
Yeah, okay.
And we don't have intersection fairings on this airplane right now.
No.
Anywhere.
Yes.
There's a lot of drag everywhere.
A lot to clean up,
Yeah, a lot to clean
And in
up.
terms of when people might see it, 12 to 18 months possibly?
12 to 18 months for kit delivery, yes.
Okay.
We'll lock down one of the kits. It'll either be the wing kit or the empennage kit.
Okay.
And deliver that first, hopefully by Oshkosh next year.
And your personal feelings about the airplane?
Personal feelings?
Yeah.
I want one on floats.
Rian Johnson, thank you very much for your time.